Students, now we are going to know about the thing by which the matter has been created. Can any one of you tell me the name of that particular thing? Yes, you, Rahul.
Sir, it is atom.
Absolutely right. Atom is the smallest thing by which matter is made. Now let us study further to know more about atom. Objectives. At the end of this lesson, you'll be able to describe the different models of an atom, recall Thomson's atomic model, discuss Rutherford's model of an atom and its defects, explain about Bohr's model of an atom, recall distribution of electrons in different orbits, distinguish between atomic number, mass number, isotopes and isobars. Atom. The word atom is derived from the Greek word atom, which means indivisible. The Greeks concluded that matter could be broken down into particles too small to be seen. These particles were called atoms. Atoms are composed of three types of particles: protons, neutrons, and electrons. Protons and neutrons are responsible for most of the atomic mass. Both the protons and neutrons reside in the nucleus. Protons have a positive charge, neutrons have no charge and they are neutral. Electrons reside in orbitals around the nucleus. They have a negative charge. It is the number of protons that determines the atomic number, that is, H is equal to 1. Isotopes. The same element may contain varying numbers of neutrons. These forms of an element are called isotopes. The chemical properties of isotopes are the same, although the physical properties of some isotopes may be different. Some isotopes are radioactive, meaning they radiate energy as they decay to a more stable form, perhaps another element half-life. Time required for half of the atoms of an element to decay into stable form. Another example is hydrogen, with atomic number of 1 can have 1, 2 or 3 neutrons. Thomson's model of an atom. J.J. Thomson proposed that an atom was a solid sphere of positively charged material and the negatively charged particles, electrons, were embedded in it like the seeds in a watermelon. The red edible part of the watermelon is compared with a positive charge in the atom. Thomson stated that an atom consists of a sphere with positive charge. Electrons are embedded in that sphere. The atom as a whole is electrically neutral since the negative and positive charges are equal in magnitude. Although Thomson's model explained that atoms are electrically neutral, this was proved wrong by the other scientists. Rutherford scattering experiment. Ernst Rutherford carried out experiment in which charged particles were shot through thin foils of metals like platinum and gold. The charged particles used were the alpha particles having mass 4 times that of a hydrogen atom and positive charge twice the magnitude of the charge of an electron. A thin foil of metal was expected to contain a few layers of atoms. The motion of charged particles incident on the foil was expected to get influenced in different ways depending upon distribution of positive and negative charges and mass within the atoms. On the basis of Thomson's model of atom, it was speculated that on passing through the metal foil, the charged particles would get deflected through a small angle. 1. Most of the space inside the atom is hollow or empty, which allows the particles to pass straight through without being deflected. 2. There is some positive center present in the atom, which deflects or repels the particles, like charges repel each other. This positively charged heavy body in the center is known as the nucleus. 3. The total volume occupied by a nucleus is very small as compared to the total volume of the atom, as very few particles are repelled or deflected by a wider angle.